I don't know the right name for review about this board. The most Chinese board, the most mysterious, the most controversial. Anyway, it's one of the most interesting. Hello, my name is Ed. And my current top edge boards for computer vision, LLM, are probably like this. Jetson Orin, Intel-based boards, Hailo or RockChip on the third and fourth place. The board we will discuss can probably compete for the fifth place, most likely with Qualcomm. But does it want to, especially outside the China? We'll be talking about a Huawei-based board, the OrangePi AiPro. The Huawei company is banned in half of the world, but it's founded by Chinese taxpayers' money, and it's actually quite a nice product. The board is produced only for the OrangePi board is produced only for the Chinese market, and it's a mystery to those who don't know Chinese and like me. However, unlike ordinary Chinese boards, it's not terrible. Well, almost. There will be a few problems. In this video, I will cover how to start the board, how to export models on this board. I will also tell you my thoughts about the quality of this board and where you should use it. And in a couple of days, I will post an article with all the sources and all the commands I will show you here. So the link will be in the description. In the meanwhile, subscribe on LinkedIn and Twitter, where the same link will be. OrangePi is based on the Ascend Ascend310B4 chip. A year ago, there was an official reference board, Atlas 200i DK A2, but before OrangePi, it was super expensive. Like, I saw prices from $500 to $1,000 for this reference board. And OrangePi actually can be a little bit different, but around like $150. And the first quest. The official site with documentation look like this. Nothing in English, and all files, as usual, can be found only on Baidu. And it's hard to download something from Baidu without Chinese account. The main guide can be found on several different sites, for example here, and obviously it's in Chinese. But when we want to speak like how to download all these system images without big problems with Baidu, there is a semi-official site, this one. It doesn't have everything, and not everyone, in my opinion, can download from it. For example, I couldn't. There is super useful site from Ascend, and it's about Atlas 200 IDK A2, which was the first reference board on this chip. And all the software is specifically for this board, not for OrangePi. But most of this software is working. I haven't tried the Ubuntu image from this site. It's like 1 GB less than OrangePi Ubuntu image, so probably it will not work. So the only one option that will guarantee you to work is take the image from Baidu. Also, I uploaded the copy of this Baidu image and stuff from this. You will find link in the description. But I'm not like 100% sure that this copy will be actual in few months, and Huawei will not ban this link. So feel free to use it, but I don't know if it's useful. Let's start from flashing. The documentation advised writing the image through Balena Etcher, but it didn't work for me. I tried a few different SD cards, a few different versions of Balena Etcher. So in the end, I wrote the image using Raspberry Pi Imager. There is a tool on the Ascend website, but it's on Chinese, so I haven't tried it. But in my opinion, usually there are a lot of tools to image your image on SD card. So there are a lot of options here. Also, you can use, instead of SD card, you can use M2 or eMMC memory. Launching. Launching is obvious. I prefer to use SSH for this. So here is like passwords for SSH, and it's better to use the second one of them. Then the working directory will be the folder with all your examples. You can connect via USB, COM port, you can directly plug in monitor in your board and run all these examples. And running the first example. I really like the way the modern boards making examples. Even in boards in which it's almost unreal to work, usually they also have some beautiful examples. For example, like check different video on my channel, like Groove Vision AI, Makes 3, or even Milk 5. So, to command will run your examples for OrangePi. First, you need to log in with Huawei AI user, which I mentioned, and SD samples notebooks, start notebooks. If you will start this with this command, you need to do a tunnel on your board and connect through this tunnel. Otherwise, you need to modify this script and allow outside users to connect to this notebook. And that's all. All the examples will run for you. I think this is the easiest and most convenient way for beginners to run neural networks on remote boards nowadays. Of course, like in professional development, you will probably use VS Code to connect and debug, or PyCharm, but when you need to do it quickly and modify just a few lines, Jupyter Notebook, it's okay. And this is the point where 99% of guides about any AI boards will end, but ours is just beginning. So let's talk about how to export your model on this specific board. And if you search in the main documentation of OrangePi, you will not find the word ONNX, TensorFlow, PyTorch. It's made me sad, but in official example export there was kind described, and it even seemed to work, that it should work right on the board. It's pretty rare. It seems that only NVIDIA prefers to convert on the boards. Almost all other manufacturers prefer to export on the host machine. So I tried, and for me it doesn't run successfully. Maybe the problem is that I have only 8 GB boards. The problem is described on Ascend site, but the solution from Ascend site doesn't work for me. Maybe because it's different board. In the example from OrangePi, they ask you to increase your swap file size. Probably it will work, but for me it doesn't help. So maybe it was like because overheating, maybe some other issues, but for me it wasn't possible to export ONNX model directly on the board. In theory, if everything is working, something like this simple script should allow you to export all your ONNX files. But let's leave this as a homework for owners of 16 GB boards, and please write in the comment, did it work for you? Also, please note super important point if you when you exporting your models. In official documentation example, there is Ascend310B1, but the real board is Ascend310B4. So check this with the command npu smi info, and if it's the same for you, please change this with corresponding. So it should be different than in official example from examples of OrangePi. So let's speak how to do this not on your board and on your host machine. As the host machine, you can like take Windows-based PC, you can take like some Ubuntu machine. For me, I just create a new Ubuntu machine like CPU and run all my experiments on this machine. So there is a way how to export your neural network on the different machine. First of all, you should to install CANN toolkit, and to install this CANN toolkit, you need to do a few actions. First of all, you should download the latest toolkit. Please be aware that when I tried to download like not the latest one, it was like 6.2, everything was not worked for me, so it was working only when I downloaded the toolkit 7.0 RS1. And please note that setting dependencies is the second important point. You should set up a lot of them. Here you can find all this, and here is like the short version. You need to update your sudo apt-get. Please install pip3, otherwise you should upgrade it. Without this it was not working for me. But the next point, you should install all pip requirements, and it's pretty sad in my opinion, because there is no like fixed list of actual version of all these environments. For example, like if you will install like pip3 install NumPy, it will install today the NumPy 2.0, and it will not work. You need to install something like NumPy 1.26 or something earlier. I don't know like what should be the actual version, because even for me there was a lot of warnings. So just try to install. If something is not working, just try to reinstall this specific pip package. So after you will install them, all you need to do is like prepare your Ascend image for run and install it. After this, everything will be ready. You need to set up all environments before your export, something like here, and everything will work for you. In different guides, all this environments preparation was a little bit different, but I hope this is what was worked for me. So let's speak a little bit about my impression from this expert. It's far from the worst board. The final guide is very simple and straightforward with no magic, but there was no ready-made guide for me anyway from the expert. No guides in internet works for me like out of the box. So it's a bad point, and searching and googling for bugs in Chinese, it's a little bit nightmare. So I will give this like 6 or 7 points out of 10 in terms of how easy to export your model. I get through all these problems like in 5-6 hours, which is not the best and not the worst result. Important disclaimer. From my experience with other boards, this guide will work for like half of a year or probably a little bit longer, but usually like vendors, they update something and guides stop working. So just use it right now. Otherwise you need to like try to fix everything. This is why I speak in the whole logic behind this guide. So let's speak about few important points about this board. Layer support. All the basic convolutional neural networks are worked pretty well for me. They all successfully exported. I tried like a few detection networks, a few classifications, there was no problem. The threshold is passed somewhere on LLM architecture. For example, like YOLO World was not successfully exported for me, and work with LLM is not quite clear. Neither Torch not Torch JIT are supported. It's only like ONNX, TensorFlow, Cafe, and MindSport support. But as you realize, most LLM doesn't even well work in ONNX. So the limitation, I think, will be more on this level. For pure convolutionals, everything will work nice. For transformers that working just with images, everything should also work, because like Dyna V2 was successful for me. But something like Whisper, I couldn't export it easily. So let's look at the speed. And the board is pretty fast. I measured everything in FP16, so be aware that you can like get like x2 or x4 speed when you will use like int 8. So let's start from YOLO V5. Inference time is here and it's quite nice. You can look at the comparison with other boards. Here I didn't have a few like modern boards like Jetson Orin or some modern Intel boards. So, but basically Jetson Orin will be faster. RK3588 in 12 threads will be faster, but it's because of the tricky 3-core MPU trick, as I mentioned earlier in my video about RK3588. Hailo 8 will be faster, but Hailo 8 is using int 8 and it's very dependent on the speed of the bus. So for example, a modern Raspberry Pi AI kit will be probably slower a little bit. And of course, like Make 3 will be probably faster, but it's super hard to use it and it's only int 8. Intel processor will be faster if it's a new processor. So in terms of time, simplicity, usability, speed, price, support, etc., probably the only one competitor with this specific board is RK3588. And of course, like if you have more budgets, just take Intel, Jetsons or Hailo, but in terms if the budget for you is important, this board is quite nice. And a few other important speeds for me, like classification ResNet 15 is 12 milliseconds, and it's faster than a lot of different boards, and Dyna V2 S and B, they're super fast. So for some tasks it's faster than RockChip and even than multi-threaded RockChip. Then in my opinion it's quite nice. Super important point, I tested with different batch size, but it didn't affect the speed at all. I didn't test like with multi-threads, maybe this will affect. I didn't test with like some C++ inference, maybe it also will be faster. Actually, there are two different options how you can utilize your chip from Python, and probably something can be optimized, but I didn't have time for this. Let's speak about a few different important points: power consumption and temperature. And it's a little bit strange. Idle consumption is 7 watt, and the temperature is super hot when the board is idle. And if you will start your computational, actually it's like will change a bit. For example, like from 7 to 9 watt, and the temperature also will be changed a little bit. But it's like it's look like some programming bug for me that they didn't like use idle mode. I don't know, super strange. So general opinion on usability, and that's when it gets interesting. Of course, I will speak in comparison with boards I did my test for, and the boards that used in critical infrastructure like hospitals, smart cities, etc. For such boards, no one in Europe or in US will use Chinese board. For this, everyone will use like Jetsons, Hailo, Intel, Texas Instruments, and other vendors. Of course, you could use like a few modern boards like SimAI, like Accelera, which like European companies, and US-based company, of course. It's quite normal for small private businesses to use Chinese boards. For example, even like in US, in Australia, in Europe, I saw a lot of projects like for pet monitoring, smart stores, like vending machine, private parking. I saw a lot of Chinese boards. Usually it was like RockChip 3588 or RockChip 3568. So RockChips is good for this. But I don't understand why anyone should switch on OrangePi actually. Because the speed difference is not critical, and like OrangePi AiPro is harder to get. It's like on risk of sanction. It's hard to export even like in different countries outside of the China. So it's a little bit complicated for me why you should use this board. But actually this board is quite nice. Probably if you do your project in China, it's a good board. Probably it can be a little bit more cheaper for big quantities than RockChip board. So it's good that we have another board. It's great that it's pretty simple. So good luck, and we'll meet in the next video.